Good evening. Welcome to the Chatham Marconi Speaker Series. My name is Liz McCart and I'm a volunteer here. We are so pleased that you have joined us tonight. Wireless technology has developed through many generations to 5G. Tonight's speaker, Arvin Singh, will discuss the potential of this technology and its impact on us. As a reminder, you can pose your questions in the Q&A box found at the bottom of your screen during the presentation. We'll have Arvin answer as many questions as possible after the presentation. It is now my privilege to introduce Arvin Singh. Arvin is the Managing Director, Global 5G and Edge Innovation for Verizon Business Group. He is leading a team of architects, engineers, and thought leaders working to accelerate the adoption of emerging product solutions such as private 4G and 5G networks, public and private edge capabilities, and managed solutions. He brings over 20 years of wireless technology experience, having served in various functions. Arvin holds an executive certificate for the Innovation Technology Leader from Stanford University and an executive MBA in Global Business Administration and Management from Pepperdine University. Welcome, Arvin. It's our pleasure to have you here with us tonight, all the way from California.
Thank you, Liz. And good evening and greetings to everyone. And Liz, thank you for that generous introduction. You're way too kind. Look, I'm excited to have this opportunity to speak with everyone today on a particularly exciting topic, and that is 5G. Verizon has been focused on several decades of bringing next generation of innovations to life. And 5G is one where we've done so many things in very unique ways. So Liz, just confirm for me that if the audience is able to see the slides, and I'll carry along. There it goes. Okay, I could see it now. Okay, fantastic. As we look at Verizon's journey, innovation is in our DNA. As we look at the next slide here, from the very first phone calls, mobile phone calls in the late 1980s, to being first to CDMA networks, and then being first to launch 4G LTE as the 4G network in the United States. And then really putting a declaration out there, getting to 5G in the United States as one of the first operators. There is tremendous first mover advantage we've gained and have taken really measured approach in building next generation of network architectures. And the beauty of this is it's not just traditional cellular-based wireless networks, but the partnerships we're forging with the industry ecosystem really to deliver the ultimate vision of 5G. And as such, as you can see on this slide, in 2020, forging partnerships with hyperscalers like the cloud providers, such as Amazon Web Services, such as Microsoft and others to come. So as we look at the journey of wireless technologies, particularly cellular wireless technology, all the way from 1G days, 1G really brought us analog voice. 2G gave us capabilities of digital voice and basic text messaging capability, right, in the 1990s. When you think about 3G, that really put mobile devices on the internet. This is basic web browsing, monochrome browsers back in the day, push-to-talk type of capabilities, some of the over-the-top type of services. Really, the cellular-based wireless ecosystem opened up when we got to 4G. In the 2008 to 2010 era is when Verizon really unveiled the 4G LTE network experience. And this opened up the ecosystem to devices beyond just smartphones, one. Two, it really took your smartphone and put experiences that didn't exist before. Consuming video, high quality video. Video used to be a thing we consume off of our traditional television sets in our living rooms, right? Mobile phones started to become the predominant tool to consume web-based video, YouTube or other user-generated content out there. Things like Internet of Things, that ecosystem opened up, taking basically cellular-based 4G connectivity, 3G connectivity into non-traditional things, be it utility meters outside your home to the connected cars and vehicles out there, and really the next generation of connectivity in those vehicles, to a whole bunch of other possibilities, from the red box DVD kiosk rentals to other things that you can imagine. 5G is expected to really blend in the cyber physical era. It's intended to really connect. It's intended to create the possibility of connecting anything that's possible out there, anything that you intend to connect that can glean meaningful insights, right? So ultimately, the ability to connect millions of things in the same general area to this next generation of network. So tremendous possibilities there, which I'll get into. As we look at the vision of 5G, just to make sure everybody's on sort of on the same level playing field, there's so much noise in the marketplace about the different types of 5G experiences and networks that are in the market. The best way to think about this is the 5G vision, the industry vision, is to really is centered around three key areas. One being really high speeds, extreme mobile broadband. We're talking about speeds that are multiple gigabits per second speeds. Think 20 peak speeds reaching up to 20 gigabits per second over time. Fiber optics like speed without wires coming down to your device, to your home, to whatever appliance that may be picking up the 5G signal, right? A ton more capacity in the network, 10 to 100 times more capacity into the network, up to 1,000 times the volume of data that can be transmitted. What this allows us to do is get into next generation of use cases. Think really real-time collaboration in the cloud, being able to engage more immersively with people sitting in Massachusetts, some of us in California, others in other parts of the globe, collaborating on the same platform. Let's say we're working on a project or trying to create a virtual visit out to one of the 7 wonders of the world, or a virtual visit to the Chatham Museum, right? So the power of the capacity, really fast speeds in the network allows for new set of capabilities that wasn't really possible in the days of 3G, 4G. Low latency is another important pillar in the 5G vision. This is really the responsiveness of the network. We're talking about a network that's 10 times more responsive than the 4G days. The reliability in this network also improves over time as part of the standards, and the vision is to get to 5 nines reliability. This is unheard of, quite frankly. Cellular wireless networks typically didn't come with this type of reliability associated with it, right? Wired connectivity, this was a norm, but this notion of ultra reliable, low latency communication will also enable a lot of different things, such as autonomous moving vehicles, ground robots, or drones and whatnot, right? So real-time applications, real-time supply chain inventory management, those possibilities can be enabled when some of these capabilities or currencies come together. Massive scale, massive amount of connections or Internet of Things devices connected in the same general area. In the days of 4G, we were talking about connecting about 100,000 things conceptually, in theory, in the same general area. In the world of 5G, we're talking about connecting million things in the same general square kilometer area. This is not Verizon saying it. Again, the global vision of 5G is to build to this type of future, one that's robust, one that offers really fast speeds, a lot more capacity in the network, a ultra responsive network that can power the needs of your business and your home today, but also bring innovations of the future, many of which that may be far from our imagination today, right? The other thing that's exciting about 5G is when we first announced to the world back in 2015, at the time, standards were still being worked upon. It wasn't finalized. The work Verizon did in partnership with the industry ecosystem really accelerated the standards work by a good 18 to 24 months. And with 5G, what's really special is the global momentum that's behind 5G. The days of 4G, when we first got to LTE, long-term evolution as the 4G standard, At the time, there were a select few operators globally that were doing 4G, right? And initially it was a handful. It was about 4 or 5 operators initially, and then the number grew to 20 or so. Today, in the 5G world, there's about a little over 200 commercially deployed 5G networks globally across 120 plus countries. So the ecosystem is going to be super robust in terms of the types of devices that will come out, the types of price points over time, the possibilities again of taking wireless connectivity, massive sensorization to places where wireless didn't go before, right? That's the potential here that the vision embarks upon as we think about 5G. As we look at the next slide here, in very layman's term, a couple things that's important to understand that's unique and different in 5G. 5G is not a replacement network necessarily for 4G. It's intended to unlock some new set of radical possibilities, right? And it's a newer technology that's sort of built in tandem with 4G. And to get to the real 5G experience, few things have to be in place. One, you need spectrum, the RF, the radio frequency waves in the network, right? Or the magic that happens between your cell phone, your mobile device to the cell tower. You need to have a lot of capacity in terms of the RF channel that's being used in order to be able to deliver on the vision that you saw on the previous slide in terms of multiple gigabit per second speeds, peaking up well north of 10, getting close to 20 gigabits over time. And I'll talk more about spectrum in a bit. You need 5G NR, new radio technology in the cell sites or the macro cell sites and the small cells that get deployed out there. This is also very important because this is not just a software flag that flashes 5G indicator on your phone. It's really making sure the infrastructure is broadcasting 5G signal. You have the right kind of fiber deployment. And this is where, again, we've made massive investments in fiber to power the full potential of 5G. And then finally, the device itself needs to have 5G radio or 5G modem in it, right? The 5G new radio NR modem. All these things come together to really create the real 5G experience, which is super important to think about it in this manner, to appreciate the journey of 5G, because what 5G was when we first launched it in 2018, and then in 2019, when we got to mobility or smartphones on 5G, to the 5G network that's in place today, it's very, very different. And it's constantly evolving and evolving for the better. We're bringing a lot more capability, a lot more capacity, a lot more functionality to the network experience, and it will continue to evolve. And this is why it's important to understand sort of the building blocks of it to realize, based on what your needs are, the kind of innovations you want to enable in future are anchored on the right network partner over time. So as you look at what Verizon did on the next slide, we really looked at the full potential of 5G and really step back to appreciate the opportunity of what is required to deliver this next generation of cellular wireless broadband experience, right? And this is where we have spent last 7 to 9 years modernizing the network infrastructure, creating a multi-purpose network architecture that is really using cutting-edge technology in the network. The radio access network, or what is known as the RAN, has been modernized. We've made investments in spectrum that are in low, mid, and high band spectrum, which I'll get into. Fiber investments that have been tremendous as well. We've made fiber optics investment of sort of Verizon-owned fiber, right? Multi-purpose network architecture that we're creating. Single transaction on fiber we did was over $1 billion to give us 36 million route miles of fiber. The number of strands of fiber we deploy is very atypical, right? It's in some cases in the major metropolitan areas, it's north of 1,000 strands of fiber. Again, a lot more capacity in that fiber network, which ends up being the backhaul or the front haul, depending on the deployment scenario. And then really this modernized packet core. On top of all that, I mentioned the industry-leading partnerships we're forging with the cloud providers like Amazon Web Services, like Microsoft, like Google for their distributed cloud edge architecture. All of these things, we've said Verizon is focused on delivering the 8 currencies or capabilities of 5G, which is right here on the wheel on the right. This is, again, just a combination of what you saw on the vision slide. We wanted to make sure we don't deviate from building to the full potential of 5G. And this is what we believe, building 5G built right. One that's built for your phones and your jetpacks and your tablets today, one that's built for your business today, and then one that's built for your innovations tomorrow, right? And that's the intent of how we sort of approach the opportunity with 5G. As you look at the next slide, spectrum is really the lifeblood of wireless networks. And 5G spectrum strategy is one where, again, Verizon has made massive bets in this space, right? We have a 4G network experience that is far-reaching, that's been out there, which we've operated in really low to mid-band spectrum. Recently, there was a lot of press where last year Verizon participated in FCC spectrum auctions to acquire mid-band spectrum, the C-band spectrum block, which I'll talk about a little bit. And then we've had high-band spectrum where we had made a couple acquisitions to acquire straight path communications and XO communications, where we got high spectrum or high-band spectrum in millimeter wave in 28 gigahertz band and 39 gigahertz band. The 4G networks of the past, when we brought all the distinct frequency bands, we're talking anywhere from 100 to 120 megahertz swath of spectrum, the channel bandwidth, right? In the millimeter wave high band, we're talking about spectrum that's far north of 1600 megahertz swath of spectrum. And we're talking about spectrum that's contiguous across the US. C-band spectrum that we picked up recently, the mid-band spectrum ranging from 3.7 to 3.9 gigahertz band. This is also very interesting because of the 280 megahertz of spectrum that was auctioned, at a minimum, we picked up 140 megahertz swath. On average, we picked up about 160 megahertz swath of spectrum nationwide. And in about 150 plus rural areas, reaching about 40 million Americans, we acquired 200 megahertz of spectrum, about 80% of the spectrum that was being auctioned. So quite remarkable because it allows us to create a 5G fabric that's ubiquitous in nature, right? And Verizon, prior to this mid-band acquisition, had invested over $159 billion in the network infrastructure, right, from the ground up, not counting the acquisitions, just measured disciplined investments to stand up next generation of infrastructure. With the mid-band spectrum, we double down on that bet by putting another $52 billion in acquiring C-band spectrum, clearing the spectrum early, working with the satellite incumbents, and then adding another $10 billion to accelerate the deployment, right? And initially, this was expected to, we were expecting to deploy about 175 million Americans within the reach of this 5G ultra-wideband network experience by the end of 2023. We are now sitting in a spot where we will deliver that this year. By the end of this year, we'll reach 175 million Americans within this 5G ultra-wideband network experience. And our 4G network and our 5G nationwide network, I'll touch on here on the next slide. Well, before I proceed to the next slide, the one thing I want to touch on, there's devices that are available on this network today, ranging from your 5G smartphones, be it Android, iOS, 5G connected tablets, even 5G connected laptops and jetpacks out there. And on the top right, you see a cube looking device that is your next generation of fixed wireless broadband appliance. Think of your Wi-Fi network in your home or even your local office, right? That cube looking device, very small footprint, is what's powering the next generation of broadband experience without wires. Really taking a 5G signal and broadcasting Wi-Fi in your home, in your place of business, and giving you much faster speeds that's built on the network, on the 5G network, with a lot more capacity in the network to be able to carry a lot more applications and use cases on it. So as you think about where we stand today. The 4G LTE network, or some of the LTE advanced capabilities that we've launched since the year 2010 in this network, it's reaching 327 million Americans today with this network and the reach of the signal, covering 99% of the population, 99% of the roadways. And this network is here to stay for the long haul. We're not trying to replace this network with what we're doing with 5G, right? On the right-hand side, you see the 5G map, where 5G ultra wideband with the mid-band spectrum, we have launched, and this network is commercially available and for use today. It's reaching over 113 million Americans today. It's reaching 30 million households across the United States and also over 2 million businesses. This is the 5G ultra wideband network. As you think about the 5G nationwide network, which is using the lower mid-band spectrum from the 4G side, that is reaching 230 million Americans across 2,700 cities in the United States. So the possibilities is really impressive. This is the public network infrastructure that we create to really give a ubiquitous connectivity fabric, right, across the nation. There's also exciting things about 5G where we get into private 5G or private 4G dedicated networks, which I'll touch on briefly. So that also gets us into different possibilities, right? And again, the intent here, as you look at this visual, is to create purpose-built networks where the radio access network and the core, packet core, is co-located on the same prem, along with potentially an edge compute appliance, like a private MEC, multi-access edge compute appliance that we're talking about. This is really promising because it's using a combination of our licensed spectrum bands, low, mid, and high spectrum bands that we own. It also uses unlicensed spectrum band, shared spectrum band like CBRS, right? So the ship-to-shore communication band. This allows the opportunity really to take the 5G and 4G network experience to places where we generally didn't build the wireless network because of whatever the reasons might have been. It was a RF challenged area, or the population density wasn't quite there, or the need wasn't quite as, the demand wasn't quite as high. Now we have a robust portfolio of this private network solutions offering to bring dedicated on-prem network experience for, be it the ports or airports, be it the education institutions, be it warehouses, manufacturing facilities, and whatnot. But the goal is we're alleviating the burden from the business. We're making it where it's a turnkey package solution, fully managed by Verizon, and it's really easy integration and easy use and consumption for the business and for the consumers that come across that business. So on the next slide is just a few visuals to give you that perspective on the use cases where we've already deployed this or are deploying and starting to really create some commercial proof points. Looking at ports, right? When you think about shipping yards, typically not a very RF radio frequency friendly environment. But given the power of spectrum that has opened up, given the modernization of technology and the easier access to capabilities to deploy now, we're able to bring on-site 5G, 4G networks to places like ports, harbors, where computer vision, combination of video camera, a edge appliance, some AI and machine learning capabilities and processing. We're doing a lot of different things around optimizing the port operations. We're also taking the same concept, the same technology, and putting it into warehouses to give visibility and create next level of efficiency, such as product quality control, catching the problems before it affects the customer or causes production delays, manufacturing process automation. There's a lot of talks about Industry 4.0 and what that could look like. And there's a lot of potential here again that is built on the backs of private 4G and 5G networks. Be it robotics, like automated guided vehicles in manufacturing facilities that drive itself, Think of it this way: the Wi-Fi networks that exist there today, it's the network for everything, right? Private on-site networks are intended to be purpose-built for that business or that mission-critical application, right? So you're not competing with everything else that may be hopping onto this unlicensed Wi-Fi spectrum band, dealing with congestion. And this allows the business an opportunity to give different treatment to the different user types in terms of prioritization with quality of service, in terms of prioritization of applications that can be enabled, be it video conferencing or something else like robotics that gets a higher priority in the network over somebody that's playing games during their lunch break or something, right? So really, really robust in terms of what's possible here. And then the final slide, I mean, again, 5G has so much potential on what we're doing with it today versus where it can go over time, and really the longer term potential of use cases to come. One of the things I'll say is we've spent the last 7 years of really testing a lot of the future capabilities in innovation sandboxes, be it Verizon-owned innovation labs or partner innovation hubs. We've also created real sort of 5G living labs or communities that are powered by public and private 5G, where different things are happening. But we envision a 5G powered future that has a lot of amazing things going on to ultimately create a sustainable society, to create elevated human experience over time, and one that is, very mindful of the planet as well in terms of energy efficiency, the footprint that 5G networks will use, given the modernization of technology. But some of the use cases, just from real-time gaming, console-like gaming experience on mobile devices on this 5G network, to think about today, video is really somewhat 2D version of video. Tomorrow, it could be very immersive video engagements, right? If you're thinking about, let's say, a biology class, students typically that had to learn about internal organs of a frog, instead of physically dissecting a frog, now you can use tools like virtual reality, VR, AR capabilities to learn the internal organs of the frog without having to harm the frog, right? So it's a win-win for the student and the frog. But similarly, being able to get to outer space exploration using this next generation of tools, user-generated content, all right? This opportunity of creating really volumetric experiences when you are, imagine you are sitting at work and your child is playing the next basketball game or their final basketball game for their school, and you're not able to make it there physically in person. We're working with venues, particularly a lot of the NFL teams, NBA teams, and even the hockey leagues already, bringing this next generation of network experience. And I would imagine the same would carry over to school systems and other places, of creating technology infrastructure that can give you presence like you're sitting on the sidelines, consuming your child playing their final basketball game of the year, right? So really next generation of possibilities and entertainment. One of the things that was showcased in terms of next gen of fan experience, when you think about Super Bowl that just happened earlier this year in February, we had at the halftime show, we had artists perform during the halftime show, and we had the NFL app and Pepsi halftime show app, where you are able to basically watch the artist performing like you're standing behind them on the stage or standing next to them on the stage. And this is, again, a combination of the power of the 5G ultra wideband network that Verizon is building, a combination of 360-degree cameras, edge appliances, bringing it all together with tools that are in the hands of our consumers and the public that can benefit from this next generation of network experience, right? Again, AR, VR, XR, this mixed reality experience, or what we are now calling metaverse, right? From going from scrolling on the internet to strolling through the metaverse. A lot of possibilities there as well in terms of what all one can experience, right? We're collaborating with the industry ecosystem. We're collaborating with device makers, with education institutions to really imagine a whole new set of possibilities depending on the vertical, depending on the industry, particularly given the tremendous economic prosperity that's tied to 5G. And I didn't touch on this early on when I touched on the vision slide, but one of the big promises to 5G pre-pandemic, when the journey of 5G started, was looking at 5G with a longer term view. And at the time, as the industry was looking at a 15-year cycle, 5G has tremendous economic promise, around $12 trillion in global economic impact, right? Just within the United States, organizations like CTIA has published stats around the employment with 5G. 3 million new jobs could be created with 5G. $300 billion worth of investments because of this new next-gen infrastructure. Like that, every industry has the potential to be transformed and disrupted to some extent, be it construction and engineering, be it maritime. We're collaborating with some of the ship-to-shore communication needs. We're looking at manufacturing, industry 4.0 possibilities. So as you think about any vertical industry, the best way to imagine this is if you had super fast speed, a lot more capacity in the network, really responsive network that is faster than a blink of a human eye, what more could we do with it? How would we reimagine a personal experience as a user, as a consumer? How would we reimagine the possibilities as a business, as a public sector operation? So Liz, I know I took sort of a broad swipe at a lot of different areas of the topic around 5G. I'm happy to take questions. I know there's a few areas that you wanted me to touch on, so I want to make sure we covered that.
Great, thank you, Arvin. That was fabulous. It really is an amazing technology, and certainly you have explained to us how incredible our future is going to be with all the work that you're doing. So thank you for that. And a reminder to our audience, and actually I don't need to remind our audience, they're already asking questions, so they're queuing them up. But I do have to say, Arvin, we could have used your 5G here tonight. We have a very bad internet signal, so I have to apologize to our viewers for that. My background has disappeared, and I don't think our slideshow came across very well, so I apologize. But in any event, your presentation came across very well. So we'll go ahead and start with our questions that we already have keyed up. And the first one is from Chris. And you touched on this, I think, a little bit in your presentation, but maybe you could expand a little bit more on how do you see 5G affecting home wireline broadband service in the long term?
Yeah, absolutely, Chris. Thank you for the question. And I think this is the other beauty that 5G, the way we've launched it today, and I mentioned 5G ultra wideband experience. Feel free to go to like Verizon.com and you can look up 5G coverage map. You could put an address to confirm if you are within coverage, because what we said we were going to do with our mid-band spectrum, right, in first half of last year to where we are in the journey, it's already reaching over 110 million Americans. So the likely chance of this signal coming to you and really delivering this fixed wireless broadband experience. So really fast broadband speeds to your home or to your business without cables, right? Without wires. Nobody has to come in and do something outside your home. It's a simple tabletop device that gets shipped to you. You plug it into the power, it registers itself, powers up, and you have access to the internet. So today that network is reaching 30 million households across America and 2 million businesses. So we intend to continue to build that at scale.
Okay, thank you. Along those lines, Mark has a question, and maybe what you just explained will answer part of it. But Verizon does not have a fiber network on Cape Cod. So are we going to be limited in our use of 5G?
Yeah, it's no, you will not be, is the short answer. Where Verizon does have fiber network, there's economic benefits to Verizon as a provider, as a technology service provider, right? It's interesting, our chief technology officer, and Kyle Malady, says 5G is really a fiber network with small cells hanging off of it, right? And that holds very true. The difference is, I guess, in that situation, Verizon has always, over the last 2 decades plus, have used either Verizon-owned fiber or third-party fiber, depending on the market or the region where we're not the LEC provider, right? So on that approach, or with that strategy, we've built industry-leading 2G, 3G, 4G, 5G networks now. So what's different now is good 40% of our cell sites are using are homed on Verizon-owned fiber. So instead of us leasing it from a third party, it's ours, and it's a different kind of fiber deployment in general. So the 5G experience we are creating will be ubiquitous anywhere you pick up Verizon's 5G signal, regardless of Verizon fiber or a third party, because that's the work we're sort of doing behind the scenes to make sure our technology partners and third parties deliver to the service levels that we expect out of them.
Okay, thank you, Arvin. Neil would like to know whether in 5 years from 6G, well, 6G, the investment in that you're making in 5G now, will it complement for 6G?
Yeah, it's look, 6G in itself is also a topic that comes up every so often. I will say a couple things on this just to appreciate the journey of the G's, right? First, it takes 5 to 10 years to come up with the next generation of wireless technology, conceptually, on paper, getting the standards to the point of where it is something that's ready for operators like Verizon and others to deploy across the globe, right? So think of it this way. 4G, when we launched commercially in 2010, we tested it for a couple of years in a couple markets, right? So from 2008 to 10 or so. That network is still here to stay and will be here for another couple of decades. So that's just giving you perspective. 10 years to come up with 4G, it's here for another 3 or 4 decades. 5G, similar story, 10 years, some in the making. We're just in the early stages of 5G. The networks are available commercially. Mainstream devices are commercially available, but the real art of the possible work, the possibilities of that 5G will help unlock, we haven't picked up the mainstream momentum on those, right? And many of these may be still far from reach or imagination today. So I will say the short answer to 6G is you'll hear a lot about 6G, but 6G won't be real for another decade, right? That's the right way to think about that.
Thank you. But it sounds like the potential that 5G has is tremendous. Maybe is it more so than the prior generations that came forward, that got us to this point?
Yeah, and I kind of went through this at a high level without going too much into the bits and bytes of the network. But Liz, you're asking a very important question. The previous generation networks, one of the nuances that's important to reference is there were 2 key criteria that one would experience as a consumer or as a business. And one was speed, the other one was latency, right? Those are the 2 main currencies that one would experience. With 5G, a lot more is being brought to the table right from the onset. And we continue to build on that foundation, right? Speed and latency are certainly there, much faster speeds, much lower latency, but then also the efficiency of the network, the energy efficiency. We're talking about softwareization of the network. Before, there was a lot of traditional vendor solutions. Think of the days of 100-foot cell towers with a base cabinet at the bottom, to the days today where small cells that get deployed in mainstream are becoming small backpack size or smaller pizza box type of deployment, right? So the modernization of the network is becoming much more power energy efficient. The devices that are coming out, particularly Internet of Things type of devices, will have battery life that's 10, 20 years longer. We're talking about, again, million things connected in the same general area to this 5G infrastructure that's being stood up by Verizon. And then another aspect that's really interesting is mobility, right? This notion of be it cars or bullet trains that are moving up to 300 miles, 310 miles an hour can sustain connectivity to this future 5G networks, right? Now, that's not all here today. That's the kind of work we're testing. We have autonomous shuttles in certain parts of America and communities that are running on our live commercial 5G networks, but those shuttles are running at a very low speed, right? They're not doing 200, 300 miles an hour. But this is where what 5G will enable is very different, because 5G brings a lot more capabilities to the table than the previous generation networks. And I think as the generations continue to evolve, the same will hold true. So a lot of these, again, will come in due time, right? Some things are here now. Some things will be addressed very differently. When you get to a private, dedicated on-prem network that's for your business, it's very specifically built for your needs, you're able to meet a lot of these criteria today. Another thing that's exciting that one may hear about is network slicing. Generally speaking, when you connect it to a cellular wireless network, all devices, all users got a pretty similar experience. Whatever network bandwidth was available, you were able to access it and use it, right? In the world of network slicing now, we're able to give different treatments to different user and application types. The individual sitting in their living room gaming on 5G broadband to their home gets a different treatment in terms of speed, in terms of security, in terms of latency, versus the individual that is running a manufacturing operation that has needs for automation within the warehouse, where there's robotics controls and things, right? So higher security, some level of data sovereignty, localized data, much faster, much higher bandwidth as well. So this opportunity to treat users and applications differently and in a much more efficient manner in the network also has benefits that users will reap over time. So it's a benefit for us as providers, but also for the consumers and businesses that serve off of this network.
Great, thanks. So it sounds like more of a customized experience, if you will. Yeah.
Context-aware network, hyper-personalized, very customized experiences, indeed.
Good. And touching on the redundancy latency issue, Neil said, is that an issue associated with built right?
Yeah, I think two-pronged response to that, Neil, and it's a great question. The reliability of 5G, just from a standards point of view, is intended to the packet failure rate improves, right? And I think on standards based on paper, 4G with 100,000 or a million packets transmitted, one packet can be dropped. In the 5G world, 1 billion packets transmitted, the intention is for one packet to get dropped. Now, we're not at that juncture today, but as we talk about private networks or dedicated 5G networks on-prem, there's levels of redundancy that can be architected. 5G radio nodes, 4G radio nodes, the packet core that's sitting on-prem, instead of a single packet core, there's a redundant hot failover packet core. All these things that can be done based on the business need and application to increase your higher availability, higher reliability, right? But ultimately, the standards of 5G with all that's possible is intended to get to 5 nines reliability. There's ways we can get to that today, depending on what we're trying to do.
Thanks. John has a question. How robust can 5G be in severe weather conditions? So does weather affect 5G?
Yeah, another really important question. Look, when we started down the path of 5G with high band spectrum, millimeter wave spectrum, right? It's much higher capacity, but the propagation characteristics of that RF frequency is much shorter reach, right? As opposed to the low band spectrums. So depending on the spectrum band, yes, the terrain, the topology it's being used in, weather could have some level of impact, but this is where the network fabric is architected in a manner to create predictable excellence or experience anywhere you go in the Verizon network. Be in Chatham, be in San Francisco, New York, anywhere, right? And part of it is because we're using, again, low band, mid band, high band spectrums. And also because early on the work that was done before standards were ratified from 2015 to 2018 era, we tested a lot of different things. Broadcasting different frequencies in snow prone areas, in really harsh weather conditions, and single pane glass, dual pane glass, brick wall, stucco, woods, trees with leaves, right? So some of the traditional RF challenges and optimizations, those hold true, but then the technology is modernizing at such a rapid pace that there's adaptive antenna arrays. 5G is a energy efficient technology in that it doesn't just broadcast the signal to everybody. It's more of a pencil beam. It's a narrow beam that comes down. It's more of a spotlight if you were standing on a stage and trying to give a talk, right? It's the signal is coming to you as a 5G user and device.
Great. That sounds like we should see some improvements sometimes in our service. Douglas,
absolutely.
Yeah.
Absolutely will.
Douglas has a question. When the FCC auctioned off the additional spectrum that Verizon purchased, who lost that spectrum?
Yeah, I wouldn't categorize it as a loss of spectrum as much as the work we did from the day one of our 5G ambitions and aspiration has been looking at to maintain US leadership in innovation and economic prosperity, right? And we were in a global race to 5G. And some countries like China, Japan, and Korea were well ahead of the race by a couple of years. So we did great body of work with the industry ecosystem, with FCC, to look at different spectrum bands, different frequencies, to make sure we make spectrum available so the 5G vision does not get stifled, not just for Verizon, for any of the US operators, quite frankly, because of the possibilities with 5G being a education equalizer, an opportunity to bridge the digital divide, to bring connectivity to underserved areas and whatnot. So when the recent spectrum that we acquired in the mid-band spectrum auction, to answer that very directly, the 3.7 to 3.9 gigahertz band that we picked up, there were some satellite providers that were incumbent operators that were on that spectrum. That mid-band spectrum, C-band, ranges from 3.7 to 4.2. What was auctioned was, what we picked up is from 3.7 to 3.9 gigahertz. And the satellite providers got relocated in the C-band, same spectrum band, just on the far end of the band. And Verizon, on our part, we paid the satellite operators to accelerate their move so we can bring this next generation of ultra wideband 5G experience to many more Americans and much faster pace.
Excellent, thanks. And here's a question from Mark that I think you probably anticipated would come up. With all the hacking that is going on, what improvements in security can we expect?
Yeah, absolutely. I think this notion of creating, ubiquitous connectivity fabrics, really the pervasiveness of devices out there, particularly non-traditional things that are connected these days, the threat footprint, the exposure for threat is much higher. The beauty about these different G's of technologies as they come, inherently the security improves in the technology. So such that in 5G as well, there's security that's inherently built in from foundationally that is twice as better as 4G, in some cases even better. For example, in the air link and the radio access network, the encryption is twice as strong, right? We're going from 128-bit to 256-bit AES encryption. There's appliances in the network like secure edge protection proxy. The methodology of user versus network authentication evolves. But ultimately, as we work with public sector, as we work with defense agencies, as we work with some of the most critical operations in the United States and across the planet, Verizon has a massive security practice. And we work with the Zero Trust Network Architecture Framework, ZTNA, right? And we're really using the NIST framework for cybersecurity. This way, there's no missteps. Security is an important responsibility that we take great pride in as a technology service provider, but it's one that we share with our partners and our customers, right? Because we need to ensure end-to-end security for data at rest, while in flight, and anywhere if it's touching the public internet, public cloud, and whatnot. So super important. I think security will remain the single most important area, and one where we have a lot of expertise and would love to partner with anybody that has immediate need around security.
Great. I think it's very reassuring considering that we know that our data is flying all over the place. So thank you for that. You mentioned an edge appliance. Can you explain a little bit further what that is?
Yeah, absolutely. Liz, thank you for that opportunity to clarify that. So today, when you do something on your device, be it your smartphone or your tablet, usually the data packet leaves that device, travels a couple hundred miles, maybe even close to 1,000 miles into the network to go fetch whatever it needs to fetch and come back. There's emerging use cases we're getting into, emerging categories of use case, where the use case cannot afford for that data packet to travel a couple hundred miles and back. We're now working in partnership with the cloud service providers to put basically smaller scale server architecture in the Verizon network for our public MEC mobile edge compute architecture. So this is within the carrier grade network. But if it's a factory operation, let's say, or a warehouse, we're putting a small scale server appliance on site, on-prem, typically in the IT or telco closet of that operation, right? This way, if it's the robots that are on the ground moving shelves of product around, when they need something, that data packet doesn't travel into the macro Verizon network, it goes to this localized edge, right? If it's something that needs to be sent over to another user in a different state, that data packet leaves that localized network and goes out to the larger Verizon network over the internet to wherever the destination is. So this private edge is one that differs depending on who you talk to. The simplest way to think about it is on-prem edge is your private edge compute, and then the public edge is what we've created in our carrier-grade network architecture, which we've done tremendous work over the last 2 decades plus to really create network environment that's highly secure, high availability, high reliability. So instead of things going to the cloud provider's operation, it's coming into Verizon's network, and the cloud provider capabilities are right there localized in that network.
Thanks. I know out of respect for your time, I'll take one more question. And this is a comment from Neil. I guess he's looking for an observation from you. Will the next Erie Canal be a drone corridor in the sky based on 5G?
It's certainly an interesting comment, right? What I will say is drone operations is real. It's something that Verizon has made acquisitions and investments to ensure that promise flourishes as well. We've been working with utility companies that have been using drones to really survey their utility infrastructure post a disaster, be it a tornado, be it a hurricane or a major storm that comes through. It's much easier and safer to fly a drone and do an aerial inspection of your utility infrastructure versus sending a field worker out there in potential danger. Verizon has also invested over a decade of doing sort of LTE airborne operations. We've been in scenarios where places get flooded and network connectivity is interrupted, and first responders show up on boats and whatnot, and there's no connectivity, but they have devices they need to communicate to each other. We've had situations where we've flown a drone up in the air that broadcasts 4G signal and uses a truck somewhere that provides the sort of the backhaul for that drone, right? This way, the operations and the communications network for that moment is up and running for the first responders. So drones has real potential, depending on where you look at it, right? I think I'll tell you, there's countries like Africa and even smaller islands in the South Pacific, like Vanuatu, has used drones for different things, from anything from blood delivery to remote areas of the country where mothers are giving birth and are losing blood, and sometimes lives are lost. Being able to deliver blood to that location using a drone, or collect a pathology sample that gets brought back, or for a remote or a virtual consult over technology. So there's immense promise there. If done the right way, lot of amazing things can be done with that.
Absolutely. Thank you. Chris, one final comment. Chris would like to say thanks for the great presentation. And I would like to echo his comment. I so appreciate your joining us tonight and answering all of these questions. You were right to reserve a lot of time at the end to answer the questions. And thank you to our viewers. You had great questions for you tonight. So in appreciation of your time, Arvin, we are going to send you this Chatham Marconi hat so that you can wear it when you come to visit us. And when you come, you will be a Chatham Marconi member, so you won't have to pay admission when you come to the museum. So we look forward to hopefully seeing you at some point in the future, and maybe even for another live presentation.
Outstanding. I look forward to that opportunity, Liz. Thanks for the opportunity today. Thanks for the audience for the questions. There's so much about 5G. I honestly couldn't do it justice in just the 60 minutes we spent together, but I wanted to share the initial framing and high level how you want to think about it. But look forward to future opportunities to come join the Chatham Marconi team and also to collaborate with you based on your needs. So thank you again, Liz, and the team for this opportunity.
Okay, thanks again, Arvin, and thanks for our audience for joining us again and the great questions. Our museum will be opening soon, so we're pleased to invite you back to see us in the very near future. And thank you again, and good night.
Good night.